Hey guys, this is Unit 2, Classifications of Matter, and we're talking about Video 2-2, Elements and Compounds. In our last video, we defined matter. Matter was defined as something that has mass and volume. Today I want to talk about matter in terms of being a pure substance, something that contains only one type of matter. Really, there's two categories we're going to talk about, elements and compounds. An element is one of the more than 111 types of matter that make up more complex substances. You can think of your elements as being the building blocks. They build all compounds. So they are the simplest pieces, the pieces that we can combine to make something more complex. Okay, again, building blocks. Compounds, on the other hand, are a combination of two or more elements in a definite ratio. Now this definite ratio idea, think of it in terms of water. Water is a compound, and water is made up of a definite ratio of hydrogen and oxygen. Water is always made up of 2 hydrogens and 1 oxygen. Doesn't matter where you are in the universe, water is always 2 hydrogens and 1 oxygen. It's a definite ratio. Let's talk specifically about elements. Elements, first of all, are represented by symbols on the periodic table. So for instance, carbon is represented with a C. Iron is represented with an Fe. Now there's going to be some elements that you're going to need to know. We'll go over those soon. I'll let you know. It'll be alright. Each element has its own unique set of physical and chemical properties. What does that really mean? It means that, for instance, with carbon, carbon has different physical properties than iron. When we look at it, they look very different. Iron is a metal, it's kind of shiny. Carbon, on the other hand, is a non-metal. It's got kind of a dark appearance if you're just looking at raw carbon. It's not metallic, not shiny. However, certain combinations of carbon can produce something that's more glass-like in the case of a diamond. Chemical property-wise, we're referring to the ability for each element to participate in certain chemical reactions. Carbon will participate in some chemical reactions. Iron will participate in other chemical reactions. They will not have the same chemical properties, which means they're not going to participate necessarily in the same chemical reactions unless they're reacting with each other. Elements, need to understand, are the simplest form of matter. Again, the building blocks. They cannot be broken down into simpler forms. Can they be broken down at all? Yes. They can be broken down, but when we do so, it basically shatters them. It breaks them up into their individual pieces, which are not necessarily easy to recombine. We call these subatomic particles because they're inside the atom, and they would be things like protons, neutrons, electrons. Compounds, on the other hand, the other category of pure substances that we're talking about today, compounds are described in chemical formulas showing the ratio of elements. Remember, compounds are 2 or more elements combined. So for example, we have glucose. Glucose is made up of 6 carbons, 12 hydrogens, and 6 oxygens. Water is another example of a compound made up of 2 hydrogens and 1 oxygen. A third example would be table salt, also known as sodium chloride. It's made up of 1 sodium and 1 chlorine. So notice here we have 6, 12, 6. Here we have 2 and 1. Here we have 1 and 1. So the ratio does not necessarily have to be always 1 to 1 or 6, 12, 6. It really depends on the chemical compatibility. Now, the other thing you should notice at this point is that there are subscripts. These little numbers right here. And these subscripts are important. They are used to show the proportions of elements in a compound. So this 6 belongs to the carbon and is telling us that there are 6 carbons, okay, in this particular molecule. There are 12 hydrogens and there are 6 oxygens. It gives us the proportions. Water, on the other hand, has twice as much hydrogen as it has oxygen. Now remember, whatever the symbol is, okay, so for instance, if our symbol is X, the subscript goes down and to the right, always. So the subscript always describes the element just before it. Now, in terms of elements, we said that they could only be broken down into subatomic particles, that they were essentially shattered. Compounds, on the other hand, can be broken down into simpler substances. When we do that, they break down into smaller compounds, smaller pieces, or they break down into their individual elements that the compound is made out of. The way you break down a compound is through a chemical reaction. Chemical reactions will change the compounds. So to give you an example, if I burn a match is made up of wood. Burning it reacts it with oxygen, so that's a chemical reaction between wood and oxygen, and it will change it into carbon compounds. Carbon compounds are those simpler substances, smaller compounds really, and water, again a smaller compound. So we've changed something large, wood, into smaller, simpler compounds. So when we're talking about compounds, understand that they are chemically combined. What that means is they have chemical bonds that are holding them together. Because of this chemical bond, when we create these compounds, they have new different properties. For example, oxygen gas, or just oxygen. It's clear, it's odorless, it does participate in fires and other reactions, it produces rust. Hydrogen, on the other hand, another flammable gas, is very, very light compared to oxygen. It also produces different reactions, participates in different reactions. It's a gas at room temperature just like oxygen. They're both odorless and tasteless. But if we put them together into a compound like water, all of a sudden at room temperature they're a liquid. Okay, still pretty tasteless, still pretty odorless, but different properties. Liquid has all sorts of other properties that we'll learn about in the future. Now, this guy here, this hydrogen, is an example of something that we call a molecule. It's a type of compound. It's a compound that's held together by a special type of bond called a covalent bond. That's all you need to know about these guys right now in terms of how they're defined. It's just a compound held together by covalent bonds. The detail you need to know in terms of molecules is just that there are diatomic molecules. Diatomics have two, and atomic means of atom. So they are molecules of two atoms. Okay, they have two atoms combined, two of the same or two different atoms, two different elements combined in a 1-to-1 ratio. And what I mean by you need to know the diatomics, there are 7 of them that you need to have memorized. This guy here, the O2, is an example of one. O2 would be 2 oxygens combined. Think of it as an atom of oxygen, and they are combined or held together chemically by a covalent bond. So this right here, this O2, we refer to as oxygen gas. This is the stuff we breathe in. Oxygen does not appear by itself, floating around in the air, meaning you don't have single atoms of oxygen floating around. You always have diatomic oxygen floating around you in the air. That's what you breathe in. So this is an example of one of the diatomics you need to know. Again, there are 7 of them. So if we list them, they are hydrogen. Off the periodic table, it forms H2. Nitrogen, which forms N2. Fluorine, which forms F2. Oxygen, which forms O2. Iodine, which forms I2. Chlorine, which forms Cl2. And bromine, which forms Br2. These are the 7 diatomics. They form molecules with themselves. You need to know these guys. The best way to remember this is to learn the mnemonic. So we've got another mnemonic. The mnemonic is, have no fear of ice cold bromine. If you remember that, you know the order. The only tricky one really is the cold. Do not think that this is carbon. Okay? It's got a C and it's got an L. So put those two together and the symbol is Cl, which equals chlorine. Alright, that's really the only tricky one. You might get confused by the H here, maybe, but really understand it's hydrogen, then you have nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. We'll take a look at these tomorrow and I'll give you a little more info about that. So just to finish this up, understand that we have talked about pure substances, which are a category of matter. So matter, okay, can be described in terms of pure substances, and we talked about 2 types of pure substances. We talked about elements and we talked about compounds. Tomorrow we're going to talk about mixtures, which are not pure substances. They are really just pure substances mixed together. They're very different because here we have a whole combination of different things, two different types of atoms, two different types of elements. Over here we have the elements separated. Okay, so we've got the big red circles, we've got the little blue circles. On the far right we have a compound. Notice here the elements are actually chemically bound together. They're stuck to each other and they're in a fixed ratio, meaning that there are 2 blue circles for every 1 red for each compound. So we have one here, one here, one here, and one here. Okay? We are done with our video. Make sure that you fill in your whisk completely. Double check you fill in all those boxes before you hit submit. Alright, and I will see you tomorrow.